Light can feel like an omen, but most eerie glows follow ordinary rules. Tonight we'll chase ship masts that hiss blue, floating spheres no one can pin down, bays that glitter like stars, and curtains of skyfire, all explained without killing the wonder. The core idea is simple. When air gets charged, when microbes flash, or when the sun hurls particles at us, light appears where we least expect it, which meant stories grow because the physics hides in plain sight. Start at sea with St. Elmo's fire, the glow sailors have whispered about since medieval logs. It is a corona discharge. Air around sharp points ionizes in a strong electric field during storms, which meant electrons strip from molecules, and the air emits a blue-violet light. Masts, yardarms, and even a captain's outstretched finger can wear faint flames that buzz like bees. Why the points? Electric fields concentrate at sharp edges. Therefore, the threshold for ionization is reached there first. On aircraft, you can sometimes spot streamers along wingtips or around cockpit windows because the same physics rides the storm with you. Is it dangerous? The glow itself is weak and carries tiny currents, but it announces trouble, which meant the surrounding field is high and lightning risk is real. Sailors once read it as blessing or warning depending on the outcome. The science says treat it as a weather bulletin you can see. A concrete anchor helps. Christopher Columbus noted a fiery light on a mast in 1493. Modern pilots still file reports after summer squall lines over the Atlantic. Therefore, the phenomenon spans centuries and vehicles. It's electricity, not prophecy. Next, the trickster. Ball lightning. Reports describe a glowing sphere the size of a grapefruit to a beach ball drifting for a few seconds, often during thunderstorms, which meant witnesses feel certain while instruments arrive late. Evidence remains thin and uneven. A handful of videos and one field spectrum suggest ordinary lightning may vaporize silicon in soil to make a short-lived plasma, and other studies propose microwave bubbles or vortex rings. Therefore, several mechanisms might mimic the same look. But controlled replication at natural scale is rare, and many sightings lack corroborating data. We should label the uncertainty and move on. Some balls may be afterimages or misread arcs in peripheral vision. Others may be real plasma behaving in messy air, which meant a single theory may not explain every story. Mystery here is mostly missing measurements, not magic. Now glide from sky to water, where the glow invites you in. Bioluminescent bays light up when tiny plankton called dinoflagellates flash as a defense, because mechanical jostling triggers a chemical spark. Each swirl becomes a neon scribble that lasts a heartbeat. Where and when matters. Mosquito Bay on Vieques in Puerto Rico is famously bright with two other bays on the island and a luminous lagoon in Jamaica. Dark new moon nights between roughly spring and early autumn give the best shows, therefore tours often time departures to the lunar calendar. Calm, warm, sheltered water and healthy mangroves feed the bloom. Ethics matter too. Lotions, bug sprays, and sunscreen can harm the plankton, which meant many operators ask you not to swim or to rinse thoroughly beforehand. Paddles disturb less than propellers. Red lights preserve your night vision. Guides watch tides to avoid stirring the bottom. Safety is mostly common sense. Wear a life vest, obey local rules, and skip trips after heavy rain that clouds the water. Therefore, you protect both yourself and the glow you came to see. Treat the bay like a living stadium with tiny players. Finally, lift your eyes to the planet's own theater, the aurora. Auroras happen when charged particles from the sun ride Earth as magnetic field into the upper atmosphere and excite oxygen and nitrogen, which then glow as they relax. That one sentence hides a cascade of beautiful details. The action sits roughly 100 to 300 kilometers above you, where green oxygen light dominates and red edges or purple fringes appear at higher altitudes. Therefore, color maps altitude and chemistry. Storm strength, often summarized by a planetary K-index, widens the glow from polar circles toward mid-latitudes, which meant rare storms paint skies much farther south than usual. The sun drives the show. Coronal mass ejections launched from active regions take a day or two to arrive, if their magnetic field couples well with ours. Energy pours into the magnetosphere and lights the curtains, therefore space weather forecasts now matter to photographers and power grids alike. A historical anchor. The 1859 Carrington event lit auroras near Cuba and disrupted telegraph lines. A 1989 storm pushed Quebec's grid to failure. Seeing one ties this episode together. You feel a myth tug at your sleeve because the scale looks supernatural, yet the ingredients are charged particles, magnetic fields, and thin air, which meant physics turns night into cathedral without asking for permission. Knowing the mechanism deepens the awe. Before we close, weigh a choice any mariner dreads. You're caught in a growing storm at sea on a small boat. Wind rises, waves stack, and the barometer keeps dropping. You must choose one plan. Anchor, run before the wind, or heave to. Anchoring can hold a hull nose to seas if you have a long, well-set road and room, but a dragging anchor on a lee shore turns bad to worse, which meant depth, bottom, and distance from hazards become decisive. Running before the wind keeps the bow with the waves and lowers slamming, therefore you trade control for speed and risk broaching if you surf too fast or meet breaking seas. Heaving to uses sail and rudder to stall the boat at an angle that calms motion and buys rest, which meant it works best with sea room and a crew that can set it up. Your decision scenario is to pick one option for this storm and defend it in one line that names the trade-off: holding ground versus control versus rest. Imagine your boat, your crew, and your nearest coast, then state the principle guiding you. We'll reveal it and highlight the best takes in the next MindMaze stream. Here's the distilled takeaway. Eerie lights feel like messages from beyond, but charge in air, microbes in water, and sunlight in space draw them. Therefore, careful physics turns legends into lessons without dimming the glow. If this episode sharpened your eye for wonder with explanations, subscribe for more mind-stretching journeys each week.